So you're given two matrices, M and N. And part A wants us to find M times N. So they're always abbreviated as MN. Now to multiply these two matrices, you have to follow a very specific rule. Okay? The key idea is to always do the row against the column. Right? And then each of this will represent a position. So let's go ahead and check this out, yeah? So it's going to be a 2 by 2. So when we do row times column, it's going to be 8 times the 4, which is 32. And then 2 times the minus 3 is minus 6. So 32 minus 6 is going to give us a 26. Now the next bit, again, we just changed another column. It's going to be 8 and 2 and pick another one, minus 1 and 5. And same thing applies. It will be 8 times minus 1, which is minus 8. And then 2 times 5, which is 10, so plus 10. And again, minus 8 plus 10 is 2. Now position is very important. If you're not sure where to position it, you'll probably notice that some of these positions collide, like 2 and minus 1. These are basically overlapping. And when you overlap them, it will appear on the overlapping position. So that's the main idea. But let's just keep going, yeah? So next one, we're going to do the next row. So it'll be 7 and 3 with 4 and minus 3. Do the same thing. So it'll be 7 times 4, which is 28. 3 times minus 3 is minus 9. 28 take away 9 is 19. And the last one, again, let me delete this bit. We're going to do now 7 and 3 with minus 1 and 5. And then do 7 times minus 1 is minus 7. 3 times 5 is positive 15. And then minus 7 add 15 is 8. And that's it, guys. That's your MN matrix found. Now the next bit, B, is known as the inverse of M. And there's two steps. The most crucial step, and this is the one that's forgotten, is to calculate the determinant of M. Now determinant M is literally something known as the pure raw value. And you find it by calculating the diagonal, multiplying the diagonal, and subtracting it with the other diagonal. So in this case, we do 8 times 3 minus 2 times 7. And when you evaluate that, you're going to have 8 times 3, which is 24, minus 2 times 7, which is 14, and it's going to give us a 10. Now this is the value we're going to use into the inverse. And to obtain the inverse, we say, alright, the inverse matrix is going to be 1 over the determinant. And it's always 1 over. So it'll be 1 over 10. And as for the matrix inside, all we're going to do now is move the M matrix values around. So for instance, we highlight 8 and 3, and we're going to swap their position. So it'll be 3 and 8. And for the other two numbers, like 2 and 7, we just stick a negative sign. So it'll be a minus 2 and minus 7. And that's it, guys. That's literally how you find the product and the inverse. Alright, number 21. Okay, so it looks like we have something known as an exponential curve. And this curve is used to measure against the number of years and the value of a given investment in dollars. So let's read the sentence below. So it says here, when Heidi was born, her grandfather invested some money in an account that paid some compound interest. The graph shows the exponential growth of the investment. So one key feature of exponential growth is that it's always increasing. So it increases slowly, then after some point in time, it just shoots up. Okay? And just a little key idea. We can see that the investment started at year 0, of course. So this is when he put the money in the bank. And this was at a value of 20. And eventually just got all the way up after 60 years to a value of something well over 360, around near 380. So let's see what the question was. So A, use the graph to find the original amount of the money invested. Well, the original amount is at times 0, so it'll be $20. B, 2, the number of years it took for the original amount to double. Now the original amount we found out was 20. We're trying to find how long it takes to double it. So double 20 is 40, and 40 occurs over here. And that means it took about 14 years. Okay, easy. Now use the graph to find the value of the investment after 54 years. So we just have to go straight to 54, which occurs around here. And going upwards, 54 years is over here, this mark here. And that's equivalent to 280. Alright, not bad. Okay, now looking at B. This account earned compound interest at a rate of R% per year. So this is a compound interest formula. Use your answers to part AI, so the 20 value, and part AII, the 14 years, to write an equation in terms of R. You do not have to solve the equation. Okay, so what it's trying to tell us is that how did we raise $20 after 14 years to get $40? Well, this is part of the usual formula, which is the original value, 1 plus or minus some rate, in this case R%, because we're increasing it by some percent, and this will give us a new value. And because we've got number of years involved, it's going to be power 14. So in this case, all you do is replace your original value and your new value with what happened to them. So the original amount invested was $20. We know we're increasing because it's a compound interest at 1 plus some R% rate. And this is for 14 years. And it will give us a new value of $40. And that's it, guys. You don't have to solve it, but this is what they're talking about. So we've got a group of 200 people who were asked which city they would like to visit next. Now here are the results. So we've got London, Paris, New York, and Tokyo. And these are the number of people that visit each of these cities or would like to visit. So we've got a person from the group which is chosen at random. Write down the probability that this person would like to visit either Paris or Tokyo next. So in this kind of question, we got 48 people that wants to go to Paris and 46 that wants to go to Tokyo. Because you want to go to either one, we have a total number of people, which means 48 plus 46. We've got 94 people that would like to visit. And this is out of 200 people. And that's it, guys. This is literally the probability. So you've got 94 out of 200 chance that out of all these people, they will be at Paris or Tokyo next. Okay? By the way, you don't have to simplify this. You could leave it like this and move on. Now B. 2 people are chosen at random from the group of 200. Find the probability that one person would like to visit London and the other would like to visit New York. Okay, so this is important. London and New York. Give your answer as a percentage. Now, if you want to visit London or New York, it doesn't specify the order. So this means that this person could go to one of the people can go to London and the other could go to New York, or they can go to New York and then the other go to London. So the way this functions is that we always have to think of this as 2 separate probabilities, yeah, in any order. So you have to rewrite orders. Now, all you have to do literally is finally work out the probability of them going to London first. Well, going to London, you got 50 out of 200 people. Now, if that guy went to London, and that means you got one less person in the group now, so 199 people, and the chance of him going to New York would be 56. And that's it. Then you've done this probability. Now for the second one, New York and London, you do the same thing. So you've got 200 people, probability going to New York would be 56. So 56 out of 200 people. Now that guy's going to New York, you're left with 199 people. And the chance of that person going to London is 50. So yeah, so you can probably see that you get the same result. And in this case, you could just work out the top one and double it. But for me, it's always safe to do them separately, yeah? So when you work out both of these fractions, you get an answer over here, and you get an answer over here. And all you want to do is add up your total probabilities. And when you add up these probabilities, you'll get a decimal answer of something like 0.14 ... And then all you have to do in your calculator is times your answer by 100 and then round it to one decimal place. So you get something like 14.1%. Okay guys, final question of the paper. So number 23. We're given 3 different functions of f, g, and h with their own expressions. Now they tell us that h at the point of 3x, so when you replace x with 3x, you get k to the power x. Find the value k. Now in this scenario, let's just highlight hx, yeah? It tells us that when you replace x with a 3x, so you have h bracket 3x, this means that the x value is now 3x. So it'll be 3 to the power of 3x. And to make this look more clear, 3 to the power of 3 is 27, so we've got 27 to the power of x. Now, in order to find the value of k, we just look at both of these. This is k to the power x, 27 to the power x. So that means k must clearly be 27. Now b. Find the value of x when the function fx equals g at the point 2. So essentially, you just have to equate fx with gx, but replace gx with an x value of 2. Let's try that out, yeah? So let's replace fx with 7 plus 3x, Let's make it equal to the g function when x is 2. So we've got 2 to the power 4. And 2 to the power 4 is 16. Now all you want to do is just rearrange and solve for x. So to rearrange it nicely, we always have to move the 7. We will move the 7 across the equal sign by minusing 7. So it would be 16 take away 7, which is 9. And then to isolate x, we've got to divide by 3. So we're going to get 9 over 3, which is 3. And that's your answer, x equals 3. And now finally, this notation is known as the inverse function of f. So all we're concerned about is the f here, 7 plus 3x. So let's go ahead and write it down for a second here. Fx equals 7 plus 3x. To obtain, to obtain an inverse of this, all you have to do is firstly rewrite this in terms of y. So fy equals 7 plus 3y, and equate it now to something known as x. And when you do this, the aim is to always rearrange and make y the subject, because when you rearrange and make y the subject, you automatically obtain the inverse. And that's it, guys, you're done. So let's go ahead and solve that equation. Yes, so 7 plus 3y equals x. Rearranging this, we could minus 7 across and then divide by 3, and you're going to have y equals x minus 7 over 3. And that's going to be x minus 7 over 3. And we're done.